Okay, woo. Welcome lesson 10.5 segment lengths and circles. You guys have done a ton of work on angles. Now we're actually going to be going into the segment lengths, all right, of chords, secants, and tangents. So the first one we're going to start with, and there's three theorems you're going to learn today. The first one has to do with chords, okay, and this is probably the most simple, all right. This is called the intersecting chord theorems, and we're going to be finding the lengths of these chords or segments of the chords. The intersecting chord theorem is just this. If two chords intersect inside a circle, and we know these are chords, why? Because their endpoints are on the circle, so that they divide each other into other parts, then this is what we know. Follow me down here. There's a formula you can use. A times, let's use uppercase A. A times B is going to be equal to C times D. And what does that even mean? Let's use that. Let's take a look here. What it's basically saying, if you multiply the length of the first segment of the chord times the length of the other segment of the chord, that will be equal to, if you multiply the length of the first segment of the other chord times the length of the second segment. All right, and let's put this to practice. Let's see if this works. So remember, first part times the second part equals the first part times the second part of the other chord. Okay, so let's try this in practice. Let's see if we can do this. All right, so for this case we want to find the value of x, and what we know is that we have our first part right here, which is 8. Okay, and we have another part of our chord, which is 12. So it's 8 times 12. All right. Our next part, we know that this big part right here of our other chord is equal to x. All right. And the smaller part is equal to 4. So it's just the big part, first part, times the second part of our first one is equal to first part times the second part. And just multiplying them out. And that's how we're going to find out x. So let's give it a shot. 8 times 12 is 96, which is equal to 4 times x, which is 4x. We divide both sides by 4, and we get x is equal to 24. Very, very cool, and very, very simple. You know, if you just know what formula to use in this lesson, you're going to be good to go. Let's try a slightly more challenging problem, but it shouldn't give us too much trouble. In the diagram below, of the circle below, chord AB, and I'm going to keep saying this until you get nauseous, but we know this is a chord because the endpoints are on the circumference, intersects chord CD at point E. Okay? We know that AE is equal to 8. We know EC is equal to 10. And we know, oh, you know what? Because it's a different line, let's put it in a different color. That's equal to 10. We know DE is equal to 6. We want to find the length of EB. You might have noticed that that just changed, so you got to edit on the spot. We want to find the length of EB. Okay. Well, hold on one sec. Well, since we don't know what EB is, let's put an X there, all right? Because we don't know what that segment is, and that's what we're looking for. And now we just plug into our formula. So the first part times the second part, 8 times x, part 1 times part 2, is going to be equal to 6 times 10. So the first part of this chord times the second part of this chord. When we do that, we get 8x is equal to 60. We're going to divide both sides by 8. And we get x is equal to 7.5. Yes, that is correct. So what is the length of EB? We can't just say x. Let's state this properly. EB is equal to 7.5. Woo! We rock and roll. All right, so that's our first formula. All right, our second formula is the two secant segment theorem, okay? And this probably has something to do with two secants. Now, the two secant theorem is if two secants are drawn from a common point on the outside, which you can see right here, then, well, let's write this down. The exterior part, okay, which would be B, that's my exterior, times my whole secant, all right, and that would be A plus B, right? So I'm adding A plus B to make my whole secant, will be equal to the exterior of my other secant, which would be right here, times the whole secant, which is C plus D. All right. That is the theorem. Now, one thing I want you to know exactly what a secant is, and let's define secant if you don't know that yet. A secant is just a line with one point on the circumference, such as right here, and one outside the circle, and one outside the circle. Okay, such as right here. Okay, a secant has one on the circumference and one outside. And why am I even telling you the definition? Well, when you're trying to figure out which formula you're going to use, you should probably figure out first, are these secants, are these chords? And if you see two secants, like we do here, then we know we should use the two secant theorem. So let's give this one a shot, okay? And like I said, if you know which formula to use, it's just plug it on in. So if you look here, we have two secants, right? One point on the circumference, one on the outside, one point on the outside. On the circumference, one on the outside. And we just have to use our formula now, okay? And our formula states that the exterior part, or A, it's our exterior, times the whole thing, right? This is the whole thing, which would be 6 plus 10, is equal to the exterior of the second secant, which is 8, times the whole thing, which would be 8 plus x, right? That's the whole thing added together, A plus B. Well, now we just have to solve, and we do that by distributing, okay? 6 times 6 is 36 plus 60. And on this side, we're going to also distribute 64 plus 8x. Well, I can add these together. I get 96 is equal to 64 plus 8x. Let's subtract 64 from both sides. We're just solving for x now. Straight on up. And what we get is 32 is equal to 8x. Divide both sides by 8, and we get x is equal to 4. So we could just fill that on in there. X is equal to 4. Easy peasy, as long as you plug into your formula correctly. So let's try this slightly harder one. Okay, in the company diagram, secant AB. All right, and this is a secant because one point's on the outside, one's in the circumference. I'm going to say it till I'm blue in the face. Intersects circle O at D, and secant AC, which is over here, intersects circle O at E, over here. Okay, so we have our circle all queued up. AE is 4. AC, which is the whole thing, is 24. AB is 16. All right, this whole thing is 16. We want to find out what AD is, okay? So let's put that as X. Okay, how do we solve this one? Well, we just use the same theorem we did before. This is the two secant theorem, and that's this. The exterior piece, which is X, times the whole thing, which in this case, we know the whole thing. We don't have to add them together. They gave it to us. So the whole thing is just 16, is equal to the exterior, which is 4, times, once again, the whole thing, which they gave to us, right? AC is the whole thing, so that's 24. So now we just solve this. 16 times x is 16x, which equals 96. Divide both sides by 16. See what I'm doing here? And we just get x is equal to 6. All right. Now that's not our answer. We want to state this properly. We want to find out what AD is, right? We said AD is X because we didn't know it. AD is equal to 6. Nice. Okay, for our final theorem, we're going to do this tangent secant segment theorem. Okay, so this is probably involving a tangent and a secant. So if a tangent and a secant are drawn from a common point on the outside, then we use this theorem, all right? And that would just be this. A, which is the exterior, oh, sorry, that's wrong. B, which is the exterior of my secant, times the whole secant, which is just B plus C, remember, that's the whole thing, will be equal to my whole tangent, which is A squared. Okay, that is my formula. The exterior part plus times the whole secant is equal to the whole tangent squared. Now once again, I want to remind you, what is a tangent? A tangent is a line that touches a circle only at one point, right? Right on the outside at one point. So we know this is a tangent because it just touches at one point, nowhere else. And we know this is secant because it has 1 point on the circumference and 1 on the outside. Okay? So let's just get busy. In our first problem, we're going to solve for x, okay? Find the value of x. Now x is our tangent, right? So we're going to put that here. X squared. Now we know our secant. We have our exterior part is 12. And the whole thing, right, would be 12 plus 4. All right. Now, before I know I distributed first, here's another way to do it. Both are equally as good. You can add the parentheses first. So this would be 12 times 16 is equal to x squared. All right. 12 times 16, let's see, that's 180, 192 is equal to x squared. And then we just take the square root of both sides to solve, and we get x is equal to the square root of 192. Now, at this point, it's probably good to get the decimal, so let's take out our trusty calculators. Grabbing my calc, grabbing my calc, and let's see. We're just going to do the square root of 192, and see if you can beat me to it right now. And that gives us 13.8, and I'm just going to round it to the nearest 1006. And that is our answer, either square root of 192 or x equals 13.86. Well, let's give this another shot. And then company diagram. Let's move this down a little. AB is tangent to circle O, so we know AB is our tangent for 2 reasons. Okay, good. All right, AB is tangent to circle O at B, and ACD is our secant. If AB is equal to 9, and AD, which is our whole thing, is equal to 27, what is AC? And since we don't know what AC is, let's put an X there. That's why I drew the X in. We don't know something, we just added in ourselves. Whoa, that was big. All right, AC is going to be our X. And let's give this a shot. Well, our tangent is 9, so 9 squared is going to be equal to our exterior part, which is X, times the whole secant, which once again was already given to us, thankfully enough, which is just 27. So we get 27x is equal to 81. 27 times x, 9 squared. Divide both sides by 27, and we get x is equal to 4. So to answer this properly, AC is equal to 4. All right, guys. So my final tip to you is this. The formulas are easy to plug into, right? You got them right here. Those are easy enough to look up. It's just knowing, do I have 2 secants, do I have 2 chords, or do I have a secant and a tangent, and figuring out which formula to use. All right, best of luck. Stay true to your heart.